Okay, welcome. This is an overview of Shelter 2.0 and the white box learning activity associated with this, what you are supposed to do. We are going to run this as a group activity, but each individual needs to do a virtual design and needs to complete the Shelter 2.0 module. So when you come in, you're going to start, as we do with all of our other ones, with the engineering research steps. You need to process each of the items that are in here. This pertains to the activity itself. It gives you the valuable knowledge base that you're going to need to make an effective design. The basic competition consists of designing an emergency shelter, picking a shape, either a rectangular prism, a hemisphere, a half cylinder, or a cylinder, to shelter 4 adult individuals. Tall hikers is our specification. They need to be able to both lay down and sit up inside of that shelter. And you need to choose one of 3 locations on a mountainside, and you need to be able to maintain a temperature that would keep them alive. I believe the minimum spec is 50 degrees, or 55 degrees, and keeping them alive. That is here in the challenge set itself. The minimum is 50 degrees. The desired temperature is 65 degrees. So your goal is to try to create the shelter out of materials that are available to you on the mountainside, and to make sure that you don't overexert your hikers as they go and collect that. So each hiker has a different maximum calorie allotment piece here. You need to understand human energy, and you're going to get that information by reading and processing the data that you see in each of the research areas. So research is a very important step. The shape does matter as well, so you choose your shape wisely. And you want to keep in mind what shape is going to be best to one, house those shelters. So you need the appropriate size with an appropriate volume inside to house those hikers. And 2, that can be insulated with a material that is not going to allow heat to escape. And so in that, you do need to understand the properties of conductive heat flow, of temperature itself, and the changes in temperature. You need to understand how surface area plays a role in conductance of temperature and heat flow and dissipating heat, how the thickness of the material is going to play a role. You want to work through, and you will be graded and evaluated on the work in each of these worksheets as part of this research. If you are unhappy with any of the grades that you earn on your worksheets here, I can reset those grades. Talk to me, I'll reset them, and you can go back and do them again. I encourage that, like all of our white box learning activities, I encourage you to use the tutorials. So this one is built into the research. There's no help tab with this, so you can just pop it up in the tutorials in the research icon. Follow through. This is an explanation of the graphic interface and how to work with the different tools here in terms of designing and setting your module. So now in the engineering tab, it's telling you, what the different icons do. The wrench is a work area, opening and closing a work area on that item. So in this case, the map and sites location. So if I click on the eye, it makes it visible. And so here we see the terrain that we're going to be building our shelter in. And you have 3 build sites. Currently, Site 1 is selected. Site 2 is an option. Site 3 is an option. And each of these sites are at different elevations. Around them are material sites that you'll build your shelters from, as well as their wooded sites where you can get wood for your shelter. If you choose Build Site 2, you ideally would not want to have your hikers go over to Site 1 for trees. You want to select the appropriate site that matches your build site area. Okay, the second icon there is the shelter's shape, and it says under shelter design, we're going to look at shape. We're going to click on the icon here, and the shape area is displayed. So I'm going to click on the wrench icon, and here is the area. Now, the default shape is a rectangular prism. You can choose one of those 4 shapes, and then you can define the size inside. I'm going to turn the eye off for the map, and I will show you the shape. So in following the tutorial here, you can also show what the people are going to look like in your shelter. Here they are laying down. If I click on the wrench here, I can show them sitting up. I want to make sure my shelter is going to have enough room to accommodate both positions, laying and sitting. And if you are following the tutorial, they're just showing you how when you change the size specifications here of your shelter, we'll do that down here, working with the area here. It says change your length to 4. So if we change the length to 4 up here, we need to make sure we hit apply. And by applying that, our length has been changed to 4. But if you notice here, I'm going to click on this little icon and rotate this around, you will see that the feet and head are sticking out. So this is not a practical size and will not work for this particular shelter. You need to make sure you can accommodate your 4 hikers laying down with their minimum specifications. I believe 6'4" or 6 foot is the hiker size itself. So in fact, we'll go back here and change our length to 6 and see how that works. Here we change it back to the 6 foot length to accommodate our hikers. Now, maybe we can get our height a little lower to trap that heat in there. So maybe we'll make it 3 foot. Don't forget to hit the apply. And laying down, they look like they're pretty good. But let's see, what do they look like sitting up? Do they have the head clearance or not? And it appears that they do. So you got a nice small structure to work with. You do have some space here on the end. You can shorten the length of your structure, so you can play around with that. Let's go to a 10 foot length, for example. Hit apply, and there it does get smaller that way. You can see that as you change these dimensions up top, the surface area that is covering your shelter, which is an important piece to the heat dissipation and also for holding in that heat, the heat retention, it changes. It reflects those changes you made up there. Pay attention to the R value, the R critical versus the R desired and R actual. And as you apply materials, this shelter doesn't have any material on it, so R actual is 0, so it is doing nothing to insulate. Once you've decided on the shape of your structure and the size of your structure, you can move on to the next step in the modeling process. So I'm going to be done with these and close those out. And I can leave the eyes on if I want to continue to see that, or I could close those out as well and just turn everything off modeling-wise. Now moving on in the tutorials, if you click next, you do get the next set in the research steps. And you would go through these research steps about energy. You would perform your worksheet about energy, and then there's a tutorial on modeling, how you actually produce your model using the criteria and the materials. And here they're modeling a cylindrical shelter as I move through. I'm not going to do that with you. You're welcome to do that with me. I'm going to move further on in here and show you what the output tab does at the lower end here. So if we click on the output tab, you're looking at the current model that I have. You see these red pieces here. This means that you are in violation, that nothing has passed. Okay, so I set a design 3 foot headroom, and you can see that it is a failure. I need to bump that up. I also set a floor length of 6 feet because that was what my people were, and I need a minimum of 6.3. So I have a failure setting here My internal temperature, still I don't have any materials on there, so it too is also failing. So when you go to your design specifications, double check and see, is your shelter in outputs, the design specifications, is your shelter passing? This one is not passing. You need to go and make the modifications that you can. Also, it is noted here that this design has not yet been saved, and that's an important piece. You want to make sure that you save your file as well. That is done over here under the File Manager tab. So just above my tutorial here, File Manager, okay, and I can save this as a working copy. It's not ready to enter competition, and maybe you can call this Design 1. So there's your, and any notes about it, it's a rectangular prism, and in comparison with other designs, you can save your working copy here. When you're ready to go to the competition, you can enter it in the competition there. Now you see Design 1 shows up down here on the bottom, and this will be updated when I reload this particular design specs piece here. So I have to exit out and then come back into it, and this will change too. So we're going to go back into the research piece to this, and we're going to jump down. You have all the knowledge about our heat transfer and insulation explained in here, and you have some worksheets that you need to do that you're going to get graded on. And after that, you have tutorials that talk about using the resources and the map and choosing and selecting a building site and then analyzing the test data. What I encourage you to do is follow each of the tutorials and use those tutorials to model your design that you wish to test. And then perform an analysis, save that. When you have a successful passing analysis, it doesn't have any red in your outputs, go ahead and enter it in the competition. Ultimately, you are to design a virtual model that we will then build in class in small groups. You are going to scale that model at a 1/10 scale, and then we are going to test it outside, and we're going to measure the heat loss that might occur from within. So good luck with this. Don't be afraid to email me or ask me in class any questions or concerns you might have.